Welcome back to Outward Home Learning. The subject is computer science, and today we're looking at mathematical operators. So to find out a little bit more about mathematical operators and how they relate to computer science, we're going to go over to Mr. Holton, who's going to tell us all about them. Over to Mr. Holton.
There are some mathematical operators that you need to be aware of that we use fairly often to solve sort of programming problems. I'm going to cover them. Don't be put off by the term sort of operator. I'm going to give you an example of what exactly an operator is because you use them all the time. Let's say in maths you've got 4 plus 3, you've got, 6 minus 2, 1 times by 9. The operator is the sign, okay? So like a plus or a minus, or in this case multiply, or really if I'm doing it for doing a proper computer science multiply, it should be that asterisk there because that's how we do multiplication in computer science. And we can have a different operator. We can actually use like a small word here, and you'll see what I mean in a moment. Let's do 7 mod 4. Okay, a mod here is an operator. It is between those two numbers and it performs some sort of function between the numbers to get a result. A mod stands for, is short for rather, modulus. And we're giving an example of just what a modulus operation is. So let's have, let's do this one. Okay, 7 mod 4. What does that actually mean? Well, it gives you the remainder of the division between 7 and 4. And for an example of this, I'm going to take you right back to primary school. And you probably learnt division, something like this. If I had 7 sweets, so let's do sweets as little circles here, and I had 4 people, how many sweets would each individual person get? But importantly for this particular problem, how many are left over? And so let's give a quick example. We've got 4 stickmen here, 4 people. So they get a sweet, they get a sweet, they get a sweet, they get a sweet. So we get rid of these sweets here. So the remainder is 3. It's these sweets here. So 7 mod 4 equals 3. See, because that's how many is left over. And it wouldn't really matter if this was like 11 mod 4. So if I did 11 mod 4, for example, that would also equal 3 because I've got, well, each person would get 2 sweeties each, but I'll end up with 3 sweets left over. How this is particularly useful sometimes is if I want to see if a number is a multiple of another number. So if I have 8 mod 4 and let's do 4 mod 4, you'll notice the results of both of them is 0, and that can be a useful trick for us. So we can put that into an if statement. So if something mod 4, for example, equals 0, then we know that it's a multiple of that number. All right, so that's modulus. Div is, I kind of think of it as like kind of the opposite of mod. So it's the number of times you can divide a number by another, but then just completely ignoring the remainder. So in this example, we had 7 div 4. So we had 7 mod 4 that equals 3. 7 div 4, well, that equals 1 because each person down here got 1 sweet each. Makes sense? But if I did 11 div 4, then we get the idea that everyone would be getting 2 sweeties each, and there'll be a remainder. So this is just simply the number of times a number will divide into another one wholly, and then you ignore any sort of remainder. Okay, the last mathematical operator we need to worry about is this funny little sign. Let's make it easy for me. 2. And then we do this funny little sign 3, and that just basically is the exponent, or you might know it as to the power of. So 2 to the power of 3, that would equal, well, it's going to be 2 times 2 times 2, which is 8 in this example. Whoops, not 3 there, which is 8 in this example. And likewise, if I did, 5 to the power of 2, like that, that's the symbol that we use in computer science, like I say, then that is 5 times 5, which equals 25. That's not 2, that's meant to be 5. 5 times 5, and that equals 25. So they're fairly straightforward. I think mathematical operators, you've got mod, you've got div, and you've got this one here, which obviously is just a symbol that you need to remember. The other thing that I'll cover very briefly is comparison operators. Okay, so let me do that in a little different colour. So comparison operators. And again, you'll be very familiar with these in maths. So let's give you an example. I've got, let's do this, 4, and then this symbol 3. So I've got 4 greater than 3, and these usually evaluate to either true or false. So is 4 greater than 3? Well, that equals True, yes, 4 is greater than 3. Let's do the reverse of that. Is 4 less than 3? Well, no, 4 is not less than 3, so that is going to equal false. And that's what usually happens. The thing we've got to be careful of is when we do this, 4 greater than 4. Okay, so is 4 greater than 4? No, it's not. 4 is not greater than 4. 4 is equal to 4, so that would equal false. That can catch a lot of people out all the time. What you may have though is a slightly different operator like this, is 4 greater than or equal to 4. Well, in that case, that equals true. Okay, so they're your comparison operators as well. And they're your main operators that you'll come across in computer science.
So your first task, based on the new information that you've got from Mr. Holton, is going to be a quiz on some of the things that Mr. Holton went through. So this won't be marked afterwards, but you will get some instant feedback on the quiz as to how you did. Off you go. So task 2 is something a little bit different. You need to open up the Practical Operators Activity Google Slides, and on there you'll see what your challenge is. It's about generating 2 random numbers in the first instance. When you've got that open, the Google slide, you can then go to the website and go on to Trinket, and Trinket will allow you to program in Python, so you'll be able to complete the challenge using Trinket. So for this, I'm going to give you about 10 minutes. You can pause the video if you need to, and then Mr. Barnes is going to review the program that you've produced from that using mathematical operators. You've got about 10 minutes. Off you go. So hopefully you got on well with that activity. Time's up and we're going to go over to Mr. Barnes, who's going to review that program with you.
Okay, so let's have a little look at this practical programming activity you've had a go at, and I'm going to go through a possible solution, but obviously there's always more than one way to do things. So we've obviously been looking at different mathematical operators, including div, mod, and exponentiation, and we've also looked at the Boolean operators and or not. So this programming activity, although pretty much pointless in what it does, gets you to demonstrate those skills. So I'm now going to talk through what the different code does, and just explain what in particular the if statements do. So at the top on line 1 we've imported the random library, and that allows us to generate the random numbers. We've then got on lines 2 and 3 two variables, one variable called number 1 and one called number 2, and then we've used the random library to generate a random integer between 0 and 100. So that's what that does. So it will generate two random numbers and store them in the relevant variables. Lines 5 and 6 are fairly straightforward. I've just printed out the numbers so I know actually what numbers each one has generated, because otherwise it's hidden in the variable and we won't be able to see. And then I've done a simple calculation because the program said it needs to add them together. So I've just said total equals num1 plus num2. So then the task said you need to decide whether the total is odd or even, and then output the result. So here on line 9 I've used an if statement, and I have said if the total variable, which is the two numbers added together, and then I put the percentage sign, and that's what we use in Python to demonstrate modulus. So if the total mod 2 equals 0, so if we divide a number by 2 and it gives no remainder, that means it's even. Otherwise it will print odd. So by using modulus and returning the remainder when we divide by 2, if it had a remainder, for example 3 divided by 2 would be 1 remainder 1, it wouldn't give us the answer 0. So saying if when we divide one by the other, if the remainder is 0, that means it must be even. Let's then go on to the next bit of the program, which said the program needs to check if number 1 is bigger than number 2 and if number 2 is greater than 50. Okay, so here we're using a Boolean operator, and we have said simply if number 1 is greater than number 2 and number 2 greater than 50, print number 1 is a big number. So we've just used the AND Boolean operator so we can check two conditions. And the final bit, which was completely random but is just demonstrating our knowledge and understanding, is it needs to check if number 1 is equal to number 2, that's fine, or if number 1 divides wholly into number 2 more than 5 times. So the first bit's fairly straightforward. We just say if number 1 equals number 2, or, and then we've got our Boolean operator, so it's one or the other, number 2, and then the // in Python means div, which is where it divides one by the other and returns how many times it goes wholly into it. So if number 2 was 50 and number 1 was 5, it would go in 10 times. Yeah, so it would give the answer 10. And then we say it's greater than 5. And then we've got the random print message that says, I am not quite sure why the program does this, but it's a good test to my understanding using mathematical operators. So in this rather pointless program, you've used modulus, you've used div, and you've also used Boolean operators, and or. Hopefully explaining that code makes sense, and hopefully you managed to do it all on your own. There are obviously other ways of doing it that give you the same end result.
So finally we're going to go and complete some exam questions on mathematical operators. As ever, this will be reviewed afterwards. You've got 10 minutes, off you go. And that is your time up, so we're going to go over to Mr. Barnes to review those answers.
Okay, so by now you should have done the practical activity and completed the quiz all about mathematical and Boolean operators. So let's have a little look at this exam question then. So we've got Grant is writing a program to keep track of appointments in a diary. As part of the program, the following algorithm calculates how many hours and how many minutes are contained in a time entered as minutes. For example, 160 minutes is 2 hours and 40 minutes. Explain the use of div in the above algorithm. So, 2 marks on offer here. Explain the use of div. So what it wants us to do is say what div does and then say what it does in this particular algorithm. So I'm going to say div completes division between 2 numbers but ignores any remainder. Okay, so that's what div does. Any remainder. Okay, the next thing then is to say what it does in this algorithm. So, you know what, if you look at this, it's pretty obvious. It says hours equals temp div 60. They're entering it in minutes, which is what the temp variable's for. So, this will find the number of full hours for the number of minutes entered. And I probably should put finds. Okay, so it finds the number of full hours because it ignores any remainder. So now we've got the next question, which says explain the use of mod in the above algorithm. Okay, so mod provides the remainder after 2 numbers have been divided. Okay, so that's what mod does, and then we need to say what it does here. So it finds the minutes left after ignoring how many full hours there are. Okay, now we're just going to have a look at the last question as well, and then we'll look for all of these as one to mark. So finally we got each appointment must be in blocks of 15 minutes. For example, an appointment for 2 hours and 45 minutes would be allowed, but an appointment for 1 hour and 17 minutes would not be allowed. Okay, so complete the algorithm which implements this restriction. So we've got temp equals input enter the time in minutes, so that takes the minutes. We've got hours equals temp div 60, which finds the whole number of hours. And then we've got minutes equals temp mod 60, which is how many minutes there are as a remainder when you get rid of the whole part. So then we've got if minutes blank 15 equals 0, then print allowed, blank print not allowed. Well, I'm going to go and answer the easy bit first of all. So we've got an if statement, we've got what to do if that's true, so this is going to be else. Okay, else do this. So one way of finding out whether a number is a multiple of another is using mod. Okay, so if you said if 4 mod 2 equals 0, that checks if 4 is a multiple of 2, which it is, because it will give no remainder. So here, if we wanted to see if we're working in multiples of 15, we can also use mod, because if minutes mod 15 equals 0, then it's allowed because it's a multiple of 15. So for example, if the minutes was 30, 30 mod 15 is 2, remainder 0. So remember, mod ignores the 2 part and just gives you the remainder. So that's like saying if 0 equals 0. If minutes was, let's say, 21, 21 mod 15 would give us the answer 6 because it's 1 remainder 6. So 6 is not equal to 0, therefore it's not allowed. Okay, so let's just double check on the mark scheme, although I sort of explained why the answers are what they are for that one. So we've got here, just shuffle it up a little bit. So it finds a quotient or uses floor division. There's lots of different types of answers here. Division ignoring the remainder. Okay, so that's where I've got my mark there. And I've said it finds the number of 4 hours for the number of minutes entered. So it finds the number of 4 hours in a given number of minutes. So the number of minutes entered. Perfect. Okay. The next one then is mod. So mod provides remainder after 2 numbers have been divided. So we've got here finds the modulus, finds a remainder after division. So I've said it is a remainder after 2 numbers have been divided. Perfect. It then finds the minutes left after ignoring how many full hours there are. So finds the minute component of converting a time in minutes into hours and minutes. So I'm saying it takes the minutes after ignoring the hours. Perfect, 2 marks. And for the last question then, if I go that way, I've already explained the reasons why. So mod can be used to check when one number is divided by another if it gives a remainder for 1 mark, and else is the else for in a statement. 6 marks.
And that's all we've got time for mathematical operators. Please stay tuned for your next lesson and keep continuing to engage with these. Well done.